If we're asked to find dy dx, that means we're asked to find the derivative of y with respect to x. In other words, we're supposed to find out how fast is y changing with respect to how fast x is changing. So we can symbolize that with the shorthand y prime. And to take the derivative, this one lends itself to the quotient rule because we have one function as a quotient of another function, one function being divided by another function. And if you were to use the quotient rule says it's the derivative of the top function. Now the derivative of the top function also needs a special rule, it needs the product rule, okay? So here, we'll call f of x the top function, x minus 1, x squared plus x plus 1, and we'll call g of x the bottom function, x to the third. And the quotient rule says that if you have f of x over g of x, then the derivative is going to be the derivative of f times g kept the same, minus f times the derivative of g, all over g squared. Okay? So we just have to plug in the derivatives where they're supposed to go, but we actually don't know what the derivatives are yet. The derivative of f needs something called the product rule to find the derivative, because this is a function of x being multiplied to this function of x. And so taking a derivative with the product rule, what you do is you take a derivative of the first function of x. So using the power rule, the 1 comes down and gets reduced by 1. So the derivative of this thing is just going to be 1 times this thing kept the same. And then the product rule says you do it again, except you keep the first thing the same times the derivative of the second thing. So it's x minus 1 times the derivative of this. And using the power rule, the 2 comes down and multiplies and gets reduced by 1. So this 2x, and then the derivative of x is 1. So this is 2x plus 1. And in case you're not familiar with what I'm doing with those constants, if there's no x, then it's not changing at all with respect to x. It's 0, right? So you could distribute that 1 if you want, or you could just forget about it because times 1 doesn't change anything. And you could expand this if you want to, but we'll leave it here in this kind of factored form. This is the derivative of f of x. The derivative of g of x is much easier, right? The 3 comes down, then it gets reduced by 1. Power rule. So we just need to plug in the original function and the derivative wherever they're supposed to go. So the derivative of f goes up here. That's going to be pretty messy. Let's clean it up, because if I try to plug this in for the derivative, it's got to be multiplied by g of x. So let's algebraically rewrite the derivative like I mentioned before. Look, if you distribute x minus 1 times 2x plus 1, you're going to get 2x squared, and then it's going to be plus x minus 2x, so that's minus an x here, and then minus 1. And then if you combine like terms, there's x squared plus 2x squared makes 3x squared. X minus x makes nothing, and 1 minus 1 makes 0. Whoa, good thing we cleaned up, because look, this and this combine to make this. X minus x makes nothing, and 1 minus 1 makes 0. So that's what the derivative of f is. So nice and simple. This is the derivative of f, and then we're supposed to multiply that by g kept the same, so that's x to the third. Minus the original f, which is kind of a monster, right? It's this whole thing. Times the derivative of g, which we found to be 3x squared. And then in the bottom of the quotient rule, it's the original g being squared. Okay, so it's x to the third being squared. Okay, and that's the derivative. The rest is just algebra, trying to clean it up and make it look nice. So this is 3x to the fifth, this term. This term is still a monster. Let's just multiply these together to start off. You might want to do that off to the side if you're not good with multiplying two parentheses with multiple terms. But I'm doing x times x squared makes x to the third. And I've got x times x makes x squared. I've got x times 1 makes x. And then a negative 1 distributing to everything. Negative 1 times x squared makes negative x squared. Negative 1 times x makes negative x. And negative 1 times positive 1 makes negative 1. And I still haven't distributed this 3x squared here. That's all over x to the third to the second. Powers on top of powers multiply. And so we've got 3x to the fifth, And it's still minus. Look, when you clean this up, x squared minus x squared makes nothing. X minus x makes nothing. And you got x minus 1, so you just got x to the third minus 1 in here. So you distribute that 3x squared into it, you're going to get 3x to the fifth minus 3x squared. That's all over x to the sixth. So now we can distribute that minus sign. You're going to have 3x to the fifth minus 3x to the fifth. That cancels out. And minus a negative 3x squared, that's just a positive 3x squared. And we have x to the squared over x to the sixth. So those powers can reduce, right? That's 2 minus 6 makes negative 4, x to the negative fourth power. In other words, 3 over x to the fourth. There's our derivative. The book gave us a real treat, huh, by letting it all simplify to be something nice.